Okay, children, before I start today's class, I just want to conclude what we have done in the previous class. Now, in the last class, we have represented all rational numbers on the number line as well as irrational numbers on the number line. Now, rational numbers together with irrational numbers makes it a set of real numbers. So when I say I can represent every rational number on the number line, every irrational number on the number line, it means can I make the statement that all real numbers can be represented on the number line? So also at the same time I can make a statement that if I take any point on the number line, it will be a real number. So this statement is true both ways, that every real number can be represented on the number line or every point on the number line represents a real number. So from now onwards the number line will be known as real number line. That is the reason we call the number line as a real number line, because every number on it is a real number. Now children, let's start with the next topic, and that is operations on irrational numbers. Now there are four basic operations: addition, subtraction, multiplication and division. You have already learned these four basic operations on rational numbers. So you can always add, subtract, multiply and divide the rational numbers. Now the new numbers that we have studied now in class 9th, they are irrational numbers. So let us see how to do addition, subtraction, multiplication and division in irrational numbers. First of all, children, you must be able to recognize irrational numbers. If I say root 5, you will say it is an irrational number. If I say 3 root 5, that will also be an irrational number. If I say 3 plus root 5, also an irrational number. 3 minus root 5, also an irrational number. This is also an irrational number. This is also an irrational number. So, whether you multiply any irrational number by a rational number or add a rational number, subtract a rational number, all these numbers will always be irrational numbers. So, now let us see how to add or subtract two irrational numbers. Let's take a very simple example first of all. Say I say 3 root 5 plus 7 root 5. Now what is important here to check is that this is an irrational number, this is also an irrational number. So in the first number, 3 is a rational number, root 5 is irrational. So one part is rational, one part is irrational. So in the second number, rational part is 7, irrational part is root 5. What is the basic requirement for addition of irrational numbers? That is that the irrational part should be same in all the numbers. Only then we can add or subtract them. So root 5 and root 5 are present in both the numbers. So in answer also root 5 will definitely be there. Now add up the rational parts. 3 plus 7 gives you 10. So 10 root 5 is the addition of these two numbers. Suppose if I would have taken 3 root 5 plus 5 root 7. Will you be able to add these two numbers? No, because their irrational part is not the same. Okay. Suppose I take the same thing goes in for subtraction also. Addition and subtraction, the same rules are there. Now suppose if I take a number as 128 plus under root 512. By looking at these two numbers, immediately you will say no, they cannot be added. Why? Because irrational parts are not the same. But remember, the first step that you should see while adding or subtracting two irrational numbers is that whether they are in the simplest form or not. So root 128, you have already learnt how to write down the simplest form. This is square root of 128, which is 2 raised to the power 7. I hope children you remember what is the simplified form. Okay, that means these three 2's can be taken out and this will remain inside the square root sign. So that makes it 8 root 2. Similarly, square root of 512. This is 2 raised to the power 9. So that makes it 2 raised to the power 2 4 times and 2 raised to the power 1. That gives me 4 2's will come out and 1 2 will remain inside the radical sign, which gives me 16 root 2. So now the simplified form of 1 root 128 is 8 root 2, whereas the simplified form of root 512 is 16 root 2. Now if you look at the irrational part of both the numbers, that is the same. That means now they can be added up. So 8 plus 16 gives you 24. Only the rational parts will be added. The irrational part will as it is come in the answer. So children, what is the first step while adding or subtracting two irrational numbers? The first step is that the numbers should all be written in the simplest form. So first, the simplest form is important. Secondly, you have to check whether their irrational part is same or not. That has to be same. Okay, then only they can be added or subtracted. Suppose now I take one more example. Say I take 3 root 2 plus 5 3 root 2 plus 5 root 7 plus 7 root 2 plus 8 root 7. Now here how we are going to add. First of all, we will group those numbers together whose irrational parts are same. So we write 3 root 2 plus 7 root 2 in one bracket, then this and this, that is 5 root 7 plus 8 root 7. As you can see, all these numbers are already written in the simplified form, the simplest form. Now what is the sum of these two numbers? It will be 10 root 2 plus this will be 13 root 7. Can they be further added? No, because here the irrational part is root 2, here it is root 7. So this is the final answer and then they cannot be added after that. Now let's take one more example of addition and subtraction. Say it's cube root of 256 minus cube root of 32 plus square root of 128 minus square root of 32. So what should be the first step? Writing all the irrational numbers in their simplest form. Now cube root of 256 can be written as cube root of 2 raised to the power 8, which is equal to cube root of 2 raised to the power 3, 2 raised to the power 3 into 2 raised to the power 2, which gives me 2 into 2 into cube root of 2 square, which can be written as 4 into cube root of 2 square will be 4. So this is the simplified form of cube root of 256. Now cube root of 32 can be written as cube root of 2 raised to the power 5, which is equal to cube root of 2 cube into 2 square, which is equal to this 1 2 can be taken out. The first one, 2 into cube root of 2 square, which is equal to 2 into cube root of 4. This is the simplified form of cube root of 32. Now under root 128 is under root 2 raised to the power 7. Square root you all know, it means here the order is 2. So square root of 2 raised to the power 2, 2 raised to the power 2, 2 raised to the power 2 into 2 raised to the power 1, which is equal to 2 into 2 into 2 into square root of 2, which gives me 8 into square root of 2. Then we have square root of 32, which is square root of 2 raised to the power 5, that is equal to 2 square into 2 square into 2 raised to the power 1, which is equal to 2 into 2 into square root of 2. So we have written down the simplified forms of all these numbers. So what do we get? Instead of cube root of 256, now I will be writing 4 into cube root of 4. Cube root of 32 is the simplified form is this. So I'll write minus 2 into cube root of 4 plus, in place of 128, what will you write? 8 root 2, and in place of root 32 we'll write 4 root 2. Now they have already been grouped together with the same irrational parts. So 4 cube root 4 minus 2 cube root 4. Here cube root 4 is common in both the numbers, so that will also come out in the answer. Then 4 minus 2 gives us 2. Similarly here root 2 is common in both the numbers, so that will also come in the answer. And 8 minus 4 gives you 4. So they can further not be added because of the different irrational parts. One is under root 2, another is cube root of 4. So these two cannot further be added, hence this is the answer. So now let us conclude that for addition and subtraction of irrational numbers, first point is that each irrational number must be written in the simplified form, simplest form, and secondly, we have to group those numbers together which have the same irrational part. Then only the irrational numbers can be added or subtracted. Now let us come to multiplication and division. As we have the same rules for addition and subtraction, we have the same rules for multiplication and division as well. Suppose I need to multiply. I will first take a very simple example, say under root 2 into under root 3. Now here we do not look at the irrational part, we just look at the order of the irrational part. What is the order of this number? Here, this is the order, this is 2. What is the order of the second number? That is also 2. If the order of the two numbers is same, we can always multiply those two numbers with the same order. Here it will be 2 and inside numbers are 2 into 3. So we'll bring them under the same radical sign and the answer will be square root of 6. If I take an example of cube root of 2 into cube root of 5. Again, the order of this first irrational number is 3. Order of the second irrational number is also 3. So the answer will be, with the 3 order, it will be 2 into 5, which is equal to cube root of 10. Suppose I want to divide cube root of, say, 15 divided by cube root of 5. Again, they have the same order, 3 and 3. So we can write it under the same radical sign, cube root 15 divided by 5. So they will get cancelled and we are left with cube root of 3 upon 1, which is equal to cube root of 3. So children, you have seen that if the order of the irrational part is same, we can easily multiply and divide two irrational numbers. So you can see the difference. In addition and subtraction, we wanted the same irrational part, means the entire irrational number should be same. Whereas in this case, we want that the order of the irrational part should be same. Now suppose I take an example wherein we have to multiply, say, cube root of 2 and square root of 3. Here there is nothing written, means it is square root. So first of all, we will see that their order is different. That means we cannot multiply these two irrational numbers unless and until their order is same. So what we do is, first of all, we find out the LCM of these two orders. One is 3, another is 2. 3 and 2. What is the LCM of 3 and 2? That is equal to 6. So we will try and make both these orders to be equal to 6. If I want to make this 3, I want to change this order 3 to 6. What do I have to do? I will have to multiply this 3 with 2. Then only I'll get 6 here. Now remember, there is a rule. Whichever number you multiply this 3 with, the same power is you have to raise to the inside number as well. So that makes it 6th root of 2 square, which is 4. Similarly, I have square root of 3. I want to change this order to equal to 6. So I need to multiply 2 by 3 to make it 6. So order 2 into 3. It means the inside number will also be raised with the same power, that is 3. Whichever number you have multiplied outside, the same number has to be raised to the power of the inside number as well. So 6th root of 3 cube, which is equal to 27. So now these two numbers can be written as 6th root of 4 into 6th root of 27. So now you can write it as 6th root of 4 into 27, which makes it 6th root of 108. One more example we'll take here, that is 6th root of 3 multiplied by cube root of 2. Here also, as you can see, the order of the two irrational numbers is not the same. So the first step is finding out the LCM of both the orders 6 and 3, which is equal to 6 in this case. That means we want to make the order of both the irrational numbers to be equal to 6. Now where you can see the first number is already has the same order, that is 6. So we need not do anything with this number. Now cube root of 2. Here we want to make the order to be 6. So 3 needs to be multiplied by 2 to make it 6. Now the same number 2 will raise power, that is 2 square. So it will become 6th root of 4. So finally 6th root of 3 into cube root of 2 will give us 6th root of 3 into 6th root of 4, which will give us 6th root of 12. So finally, what are the important points to note while multiplication and division? First thing that you have to remember is that if the order is same, order of the radical sign of both irrational numbers is same, then they can be directly multiplied or divided. But second case is if their order is not same. If the order is not same, then what do we need to do? We have to make their order same. Make the order same and make it equal to the LCM of the two orders. Okay children, after completing the operations on irrational numbers, let us start with rationalizing factor. What is the meaning of rationalizing factor? We can find out the rationalizing factor for irrational numbers only. Now what is the meaning of rationalizing factor? Rationalizing factor means that number which can make the given irrational number a rational number. That is known as a rationalizing factor. I'll make it more clear with the help of an example. Suppose I take square root of 32. As you all know, it is an irrational number. Let us see why it is an irrational number. We'll first convert it into the simplest form. Converting irrational numbers into simplest form is a very important thing to do. So we can write it as 2 square into 2 square into 2 raised to the power 1, which will be 2 square into square root of 2 square into square root of 2 to the power 1. So these 2's will come out of the radical sign, and we are just left with 1 2 inside the radical sign. Now this is an irrational number. I want to find out the rationalizing factor for this number, or this number, anything you can say. Either you say square root of 32, or you say 4 into square root of 2. How can I make this number a rational number? The basic thing is that I want to get rid of this number because it is in the radical sign. Here the power of 2 is 1, whereas the order of the radical sign is 2. So when both these numbers they become same, then this number comes out of the radical sign. So how many more 2's are required to be multiplied with this number so that it can come out of the radical sign? Obviously 1, because 1 2 is already there. I need, this number is already there, I need one more 2. But if I simply multiply by 2, I will not be able to multiply these two numbers. So what will I do? I will take square root of 2. Now what do I get if I multiply these two numbers? I will get square root of 2 into 2, or 2 square, and ultimately this will also come out of the radical sign, and we will finally get a rational number. So this was the number which made the given irrational number to a rational number. Hence, under root 2 is the simplest rationalizing factor for cube square root of 32. Okay, I am saying simplest rationalizing factor. Now as you can see, if I now multiply square root of 32 into square root of 2, I will get square root of 64, which you all know is equal to 8. So it's a rational number. Hence I can say root 2 is the simplest rationalizing factor for root 32. Suppose if I multiply root 32 by 5 root 2, again 5 being a rational number will stay outside the radical sign. Inside the radical sign I will get square root of 64. So ultimately I will get 5 into 8, which is equal to 40, which is again a rational number. So that means root 32 could be converted into a rational number even if I multiply it by 5 root 2. That means that can also be considered as a rationalizing factor for root 32. Similarly, if I multiply root 32 by say 15 root 2, even then I will get 15 into square root of 64, 15 into 8, which is equal to 120, which is again a rational number. It means how many rationalizing factors I can find out for a given number, that is infinite. I can find infinite rationalizing factors for any irrational number. But we are always interested in finding out the simplest rationalizing factor, and for that the procedure is the one which I showed you in the example. That is the way to find out the simplest rationalizing factor. First step is to convert the given irrational number into the simplest form and then find out its rationalizing factor. Now suppose I take another example. Say I say cube root of 4. Again, let me check out the power notation here. 4 can be written as 2 square. It is an irrational number. Why? Because the order of the radical sign and the power of the number are not the same. They are different. So this 2 cannot be taken out of the radical sign. So tell me, if this order is 3, here the power is 2, how many more 2's I want here? I want one more 2 to be multiplied, but under the same radical sign as 3. Then only I will be able to multiply these two numbers. So it will be cube root of 2 square into 2 to the power 1, which will make it 2 cube, and hence the answer is 2, which is a rational number. It means this was the number which converted the given irrational number cube root of 4 into a rational number, that is 2. So cube root of 2 is the rationalizing factor for cube root of 4, is in fact the simplest rationalizing factor. There can be so many other rationalizing factors for this. I can say if I multiply cube root of 4 with say 7 into cube root of 2, then what will I get? 7 into cube root of 2 cube, which is equal to 7 into 2, which is equal to 14, which is again a rational number. Hence I can call this also as the rationalizing factor. So in the same way, as I told you, there can be infinite rationalizing factors for a given irrational number, but we are always interested in finding the simplest rationalizing factor for the given irrational number. So that was the rationalizing factor for monomial irrational numbers. Now let us find out the rationalizing factors for binomial irrational numbers. Say for example, let's take root 5 plus root 3. How can I make this number a rational number? Suppose I multiply this number by root 5 minus root 3. Okay, this was the given number and I am multiplying it with this number, and let's see what is the result. Now children, this is, you can apply the identity here, a plus b into a minus b. So what is that equal to? A plus b into a minus b gives you a square minus b square. So here I will get root 5 whole square minus root 3 whole square. What is root 5 whole square? That gives you 5. Root 3 whole square gives you 3. That comes out to be 2, which is a rational number. It means I can say root 5 minus root 3 is a rationalizing factor for root 5 plus root 3, or I can say root 5 plus root 3 is a rationalizing factor for root 5 minus root 3. Similarly, if I take another example, say 2 plus root 3. What is the rationalizing factor for this? I can take it as 2 minus root 3, which gives me 2 square minus root 3 square. 4 minus 3, which is equal to 1, which is a rational number. Hence, I say that 2 minus root 3 is a rationalizing factor for 2 plus root 3, or 2 plus 3 root 3 is a rationalizing factor for 2 minus root 3. Again, this is the simplest rationalizing factor. Suppose with 2 plus root 3, I multiply it with 4 into 2 minus root 3. What you can do is 4 can be written here, and then we can finally multiply these two brackets, this and this, will get 2 square minus root 3 square, which gives me 4 into 4 minus 3, that is 4 into 1, which is equal to 4, that is again a rational number. Hence again there can be infinite rationalizing factors for any type of irrational number, but again I'll tell you, we are always interested in finding out the simplest rationalizing factors of irrational numbers.